So yeah, that's me. You're probably wondering how I got in this situation. Well, let me tell you the story. It all starts with a guy named Dylan. So here's Dylan. He's upset because he just failed a midterm of Dr. Plunkett's.
Oh man.
To get his revenge, he devised a plan to kill Dr. Plunkett, but he didn't want to get caught. So he thought to himself,
Hey, maybe I could frame Micah.
and here's how he's going to frame me, his lab partner Micah.
I can get some of his blood from A&P lab, some skin cells from his arm, but how will I get him leaving the scene of the crime?
So Dylan called me up the other day and told me to meet him in the other lab so we could counter E. coli colonies. When I got there, he wasn't there, so I checked the other lab, but it was all locked.
Oh my God.
What?
What is it?
What
happened?
Is there news?
There has been a murder.
What?
What?
Later that day, Plunkett's lifeless body was found. He was lying in a pool of his own blood next to a scalpel with some skin cells on the handle, and there was a trail of blood leaving the lab. 4 suspects were seen leaving the scene of the crime: the janitor, Jessica, Micah, and Dylan. In order to extract DNA from all 4 suspects, they had them swish around a saline solution in their mouths for a minute. After that, they spat out the backwash back into the cup, which contained some of their cheek cells. This backwash was then spun down in microcentrifuge tubes to get a pellet made of the cheek cells. These cheek cells were then lysed in order to get at the DNA inside the cells. This DNA is then amplified using the polymerase chain reaction, also known as PCR. This is accomplished by first denaturing the DNA at 94 degrees Celsius for 30 seconds. Primers are then allowed to anneal at a temperature of 65 degrees Celsius for another 30 seconds. An enzyme that can withstand the high heat, known as Taq polymerase, then binds the DNA and catalyzes the extension of the DNA strand at 72 degrees Celsius for another 30 seconds. This process is then allowed to continue 35 times. In the case of our cheek cells, we will be using an analysis known as VNTR, which stands for Variable Number Tandem Repeats. This type of analysis is done on sections of the genome that have repeats of 10 to 100 base pairs. This allows us to differentiate between DNA extracted from different individuals, as people generally do not have the same amount of repeats in the VNTR sequences. Another type of analysis that can be done is known as STR, which stands for Short Tandem Repeats. The process for STR is similar to that of VNTR. The DNA is first amplified by PCR and then cut by restriction enzymes. However, for STR, the repeats are only 2 to 16 base pairs, a lot shorter than in VNTR. Again, we can distinguish between DNA extracted from different individuals based on the number of base pairs per repeat. Restriction fragment length polymorphism, or RFLP, can be analyzed in the same way as STR and VNTR. However, amplification by PCR is not required, as the fragment lengths are long enough to perform gel electrophoresis on their own. And this is how the gels are made. First, TAE buffer is added to an Erlenmeyer flask. Agarose powder, which is derived from seaweed, is then added to the TAE buffer. If you want to make a thicker gel, which is good for analyzing smaller fragments of DNA, more agarose powder can be added. After your gel has hardened, different samples of DNA can be added to the wells. We usually put a DNA ladder, made up of known fragment sizes, in the first well, so as to have a scale to go off of when measuring our other DNA bands. A dye is also added to the DNA fragments in order to weigh them down in the wells and to enable us to monitor the process of the electrophoresis to ensure that the DNA bands don't run off the edge of the gel. As previously mentioned, when dealing with long DNA strands, as when analyzing RFLP, it is better to use less concentrated agarose. This allows for more free movement of the long strands of DNA through the gel. However, when analyzing STR or VNTR, we use a more concentrated agarose. This allows for the shorter strands to move slower, allowing for greater separation of the bands. Let's take a closer look at the gels that we analyzed in lab. In the first well was placed the DNA found at the crime scene. We found that it matched the well for suspect number 3. This was for the RFLP analysis. The next gel that we'll look at was done for the STR and VNTR samples. In the first well, we placed a DNA ladder to help us figure out the lengths of each of the strands. In the second well, there was DNA found at the crime scene. We found that it matched suspect number 3. And here are the bands for my VNTR analysis done from the DNA extracted from my cheek cells. I was found to be heterozygous for the sequence that we were analyzing. Now, let's get back to our crime scene investigation. The 4 suspects were the janitor, Jessica, Micah, that's me, and Dylan. I've redrawn the gel for clarity here. Now, if we compare the DNA found at the crime scene to the janitor's DNA, Jessica's DNA, Micah's DNA, and Dylan's DNA, it was found that Micah was the killer. So in the end, Dylan did a pretty good job at framing me for Dr. Plunkett's murder, and that's how I ended up behind bars. The DNA evidence alone wouldn't have been enough to convict me, but because Dylan had me leaving the scene of the crime, it was too easy for the jury to find me guilty.